Alright, so in this one we have a parallel circuit. The power source is 64 volts and it's connected to 4 resistors. So the first resistor is 20 ohms, the second resistor is 25 ohms, the third resistor is unknown, but the fourth resistor is 50 ohms. They do tell us that the total power for the entire circuit is 567.59 watts. So from there we can figure out the total resistance. So if you remember, power is I times V. V is I times R. If I rearrange V equals I times R, I can get that I is V over R, so power actually becomes V over R times V, or V squared divided by R. So I'm going to use that equation to figure out the total resistance because I'm using the total power. So total power, which is 567.59, is equal to V squared, the total voltage, so 64 squared divided by total resistance. So the first thing we need to do is multiply each side by the total resistance and then divide by 567.59, and we solve for the total resistance. We will get a value of 7.216 ohms. Then from here, I'm dealing with a parallel circuit. So with a parallel circuit, remember that total resistance in this case is going to be 1 over R1 plus 1 over R2 plus 1 over R3 plus 1 over R4, all to the inverse. So when I plug in my values, I have 7.216 is equal to 1 over 20 plus 1 over 25 plus 1 over R plus 1 over 50, all to the inverse. So the first thing that we need to do is we have to take the inverse of both sides. Alright, so we need to take the -1 of both sides to get rid of it. And so that will give us 0.139 is equal to, and I'm going to go ahead and reduce the 1 over 20 plus 1 over 25 plus 1 over 50, and that's going to give me 0.11. So I want to subtract that from both sides, and that gives me 0.029. Now I've been doing this in my calculator, and as I'm writing only 3 decimal places in my calculator, I'm keeping all the values out. So when I do this last step, which is the inverse of 0.029, keep in mind that in my calculator I kept the full decimal. So this will give me R3 is equal to 34.99 ohms.